Okay, problem 6. Solve the linear system by Kramers rule, if it applies. Okay, so what are we doing here? We're trying to solve the system of linear equations. Okay, we're trying to solve system of linear equations. Okay, before learning matrix, how do we do that? Right, we do substitution, we eliminate variables, right? We keep eliminating variables until we have only one variable, one equation. We get that variable, for example, the value of x, and then sub back. Okay, then get another variable, then sub back. Okay, that is what we did before we learned matrix. Now, because we already have such a powerful tool, so we can apply something which is much easier. Okay, so first we can, for the left-hand side, we can separate the coefficients, right, with the xyz. So we separate the coefficients with the xyz. Separate the coefficients with xyz. And on the right-hand side, we put it down here. Okay, now let's call this coefficient matrix A. Okay, so if A is invertible, which means if the determinant of A is not 0, then the system, right, this system of linear equations, has a unique solution. Okay, and if the determinant of A is 0, then, okay, the system of the linear equations has either no solution or infinitely many solutions. Okay, when no solution, when infinitely many solution, that depends on the right-hand side. Okay, the right-hand side, we're determining whether that system has no solution or infinitely many solutions. Okay. So here's a conclusion. If it has a unique solution, right? If it has a unique solution, so we don't talk about this here. If it has a unique solution, then we can apply something called the Kramers rule, and we can immediately get those solutions. Okay, how do we get the solution? Right? What is a Kramers rule? So what is x? What is y? What is z? Right? The values of these variables are what we are interested in. So the value of x, okay, is something over the determinant of a. Okay, this is just a, so you just get the determinant of a. Okay, then what is on the top? Let's remove it. Okay, that's just on the top. We just need to replace the columns corresponding to x with the right-hand side value. So for example, in A, you can see this first column is corresponding to x, right? You can see the x coefficients 4, 11, 1. That's the first column of A. Right, so we just replace that column with the right-hand side value. Okay, so I do that. It's 2, 3, 1. Okay, this becomes the first column, then 5, 1, 5. 0, 2, 2. Okay, this will be the first column. Okay, this will be the first column over the determinant of A. So you just get this new matrix determinant over the determinant of A, you'll get the answer. Okay, so let's do the determinant of A. Okay, here now you should be very familiar with how to get the determinant already. Okay, so I won't talk about, I won't do all the details here. Okay, or I just do the details of A. Okay, then you can do the rest by yourself. So A is this coefficient matrix. Okay, what is its determinant? All right, first choose a row or column. So I choose the first row because it has a 0 here. I like it. So it's 4. Right, it's 4 times -1 to the power of 1 plus 1 times the determinant of this. Okay, plus 5 times -1 to the power of 1 plus 2 times the determinant of this. Okay, plus 0 times, I don't have to write it down, but to get yourself familiar with this formula, you just do this. Okay. Then the first part is 4 times 1 times z's determinant is 1 times 2 minus 5 times 2. So it is -8. Right? Plus 5 times -1 times, right, this is 22 minus 2. So it is 20. So the result is -100 minus 32. So it's -132. Okay, then this determinant you can calculate in a similar fashion, right? It will be -36. So x1 is this, right? The result is 3/11. Y is, okay, y is you replace the second row, right? The second column, right? Because here there are y's coefficients. To replace the second column with the right-hand side. Over the determinant of A. Okay, you get the determinant of the top, it's -24 over -132. Okay, so that would be 2/11. Then part Z is, you just replace the last column with the right-hand side. So 4, 11, 1, 5, 1, 5, 2, 3, 1. Okay, over determinant of A. So it will be 12 over -132. It will be -1/11. Right. So these are the solutions. So for Kramers rule, we use it to solve the system of linear equations. And if the coefficient matrix determinant is non-zero, it has a unique solution. We just use the Kramers rule to get the solution. Right. That is question 6.